Okay, so I've been told to start. Oh my God, can you mute yourself? Oh my, please mute yourself because I can hear myself. So okay, I've seen both muted now. Okay. Okay, I hope you can hear me now, and I don't hear myself. So welcome everyone for today's talk presented by me. It was prepared by me and my colleague Pavel, but Pavel will not be joining us today. I will be available on Slack still, even after this presentation. So if you have any questions that we don't answer during this session, then I will be still present and available for discussion on Slack. And later, we can always get in touch via mail. And for now, I'll start. So today, I want to talk to you about pleasure, actually, because Piacere is the Italian word for pleasure. It's actually an acronym for this project's name. I will show it later a bit, but it revolves around this concept of DevSecOps and automation in DevSecOps. So think like CI/CD in DevSecOps. Okay, and the company that I represent, so this is a European Union project, and the company that I represent is called sevenbulls.com actually. So the company's name is actually the DNS name that you can find us on. Very useful, I would say. We act here as a research and development center. We are actually registered as such in France and Poland. So our main country is Poland, and we are also registered in France. You can now see how Research and Development Center is named in France and in Polish, in French and Polish. Apart from R&D, we are mostly an IT company. So like the majority of our employees are IT specialists. We are doing IT for IT by IT, basically. And in various branches of IT, so like the consulting, software engineering, and various others. You can find all the details also in English on our main page, sevenbulls.com. If you are especially interested in R&D stuff, then it's /R&D and you'll find it there. And now a little bit about DevSecOps, because obviously it's some other funky name that the community is using for the technologies that are being prepared nowadays for coordinating IT infrastructure in companies. And this is the definition. It's taken from the Gartner's IT glossary. So the go-to point for the information about the different names that are being used nowadays. And you've most likely recognized the dev and ops part of this. So the DevOps, as it's been a much more popular name for the concept of making operations in IT more automated, using the development tools, using the developmental approach that is used for building software, also for building the infrastructure itself. So the concepts like infrastructure as code, etc. And now this is actually enhancing it with security in mind. The security is placed in center on purpose, so that this says that the security is the most important part of this DevSecOps approach. So the real focus of this new trend. And the goal of DevSecOps is to naturally not impede the progress that is made by moving from the ordinary tooling to DevOps tooling, so that the agility that is gained is not lost in the process of doing the security stuff additionally to doing DevOps. So that the DevSecOps is as easy as DevOps, but includes security as a main point, as a main focus. That's what the definition says. And I hope I don't have to persuade you why security is important. So like almost every day, if we go to look at some hacking happening around the world, we always see there is something to improve in the security that we have in IT, globally speaking. But if we consider that moving from the traditional roles where traditional models where there was a lot of nitpicking on the configuration and a lot of manual process and design, in this new DevOps world, there is much more automation, and this automation can introduce other surfaces of risk, other ways for our IT infrastructure to be insecure as a result. So we argue that it is still important to focus on security, or even more important to focus on security in this new DevOps world by introducing this DevSecOps approach. The other parts that arose from DevOps mostly, so the heterogeneity and the fact that it's happening frequently, so it's more often the case that change is the only constant, basically. That's the saying. And introducing security into that constant sounds like a good promise. And here we are introducing Piacere. So as I said previously, it's an Italian word for pleasure, but the acronym of the project is actually Programming Trustworthy Infrastructure as Code in a Secure Framework. I always hope that nobody wakes me up at 2 a.m. and asks me what Piacere stands for, because I will not be able to tell that. Basically, this is too complicated. But focusing on the fact that this is about the infrastructure as code and about doing it in a secure way by offering a framework to do that, is basically what this project is all about. As the slide says, it's a Horizon 2020 project, so it's financed by the European Union. The consortium that we have consists of 12 organizations. They are from different. They have different experiences. So we have academia, business, government. Like for example, from the business, we have large enterprises like HP and Ericsson. From academia, we've got Politecnico Milano. From Italy, and the project itself is led by a group from Tecnalia from Spain. They are in similar role to us, so like a research and development center there. The schedule of the project, it's actually in an early stage, so it hasn't, not even a year has already passed. I'm showing you really early designs today and early approaches, and I'm very open to the discussion in general. So that's what what you can expect for today. We are 7 bulls in this project. We are mostly responsible for the integration of the final solution and the Canary Sandbox environment. I will also explain what it means later on the slides. And what about the goals of this project? So Piacere DevSecOps, the project is called Piacere, and DevSecOps is what it is meant to achieve in that. So basically what the DevOps lets you to do, so developing, building, deploying application, that's what you are provisioning your IT infrastructure for, basically. So it still must to do that. Additionally to that, we always speaking about this avoiding of vendor lock-in. So going for hybrid and multi-cloud deployments with cloud agnosticism, that you don't have to go and choose only one cloud provider, which also brings other benefits later, like for example, this bullet on the optimization of usage of resources, since you can easily swap out the environments for the other clouds if the other clouds are more optimal for your solution at the moment. Of course, including the costs of transit. So like if the transit is too costly, then this solution wouldn't be proposed as an optimal one. Additionally, testing, because testing is actually paramount for the security. So basically how we achieve the security is that we propose testing, and the testing is customized for the user. But there are always general principles that this framework is going to apply to the process of DevSecOps. And another paramount thing to avoid the snowflakes. So before the DevOps era, we had this trend that every server was a pet. called otherwise a snowflake, that it was crafted to work the way it worked. Um, and this philosophy kind of infiltrated the DevOps approach, so that the DevOps is mostly, as it can be seen in various companies, it's not clear DevOps. We still see snowflakes happening. So this project is also aiming to ensure that the users are more likely to focus on the DevOps as it was meant to be, rather than DevOps revolving around the snowflakes. But obviously, we cannot block that. Right? Okay, so regarding key features, as I've already mentioned, I guess most of those points. So integrating the security principles into DevOps, agility without losing the security, or otherwise security without losing the agility. The sandboxing, so the Canary sandbox environment that was already mentioned. So an easy way for you to set up an environment that behaves similarly to the cloud provider, so that you can test it. You can test your infrastructure as code in a similar environment to test some dynamic properties. Also regarding those avoidance of snowflakes, etc., config drifts, single source of truth. So if you recall the concept of GitOps, I will show that on the screen as well. Cloud agnosticisms, I've already said that. Automatic healing optimization. So if we consider optimization, some optimization is like for the cost, for the trade-offs, but a more general concept of healing. So when the toolkit is actually able to discover that there was a drift, an unplanned drift, that you could say in general should be optimized away. But this is a quick action, like restoring your service to work in the very same environment. Actually, that is what we call safe healing, automatic healing. And here is a little diagram for you how this Piacere DevSecOps framework is thought to work. We've got a part for design time. This is in the left upper corner of the diagram. I don't know if your screen is able to display it in Zoom enough to be readable, but I will try to explain what's in there anyway. So at the design time, the tooling that we are providing in the framework is plugins for Eclipse IDE. This is actually, we are still on a stage of researching whether the Eclipse, the classical Eclipse that you know in Java that is desktop based, will be better, or if the new Visual Studio Code Eclipse Share will be a better solution for this particular project. Also because there is quite an abundance for tooling for modeling in the Eclipse traditional, that we are still considering trade-offs that we have in this particular choice. But basically, there will be some IDE, either web-based or desktop-based, that will be able to manipulate the new language that we are going to propose in this project for modeling the IT infrastructure, the generalization of infrastructure as code, so to speak. This language is called DOML. There will be a screen explaining it in a more detail soon. Now just focus that the DOML is the language that is going to be used for modeling in this IDE. And then this DOML model that the user prepares for themselves is going to go into the infrastructure code generator and parallelly to the verification tool. And the infrastructure code generator is actually to reformulate this DOML model into infrastructure as code that is generally acceptable, like, for example, the Terraform or the Ansible playbooks, etc. And the verification tool also gets fed that. So the verification tool is able to read what the user had in mind in the DOML model, and we will see the complexity, the extensivity, let's say, of the DOML soon, and also the generated infrastructure as code, and do all the necessary static analysis on that. Then with that, it moves further if it's accepted. So if either there were no issues or the issues that they were discovered, user is aware of and accepts, then this moves on to the Git repository. So some tooling gets a PR this PR can be approved then by the person that is allowed in this Git repository doing. So think like GitHub or GitLab or Garrett perhaps, some owner of the application or the deployment is able to decide that it goes in. And as it goes in, there's the runtime controller that watches that, gets notified and retriggers the deployment. The deployment is actually handled by the thing that we call IAC Executor Manager, as it manages the executors of IAC, like for example, this Ansible or the Terraform. And the IAM then moves some information to the infrastructure elements catalog. This catalog is also usable by the IDE for the discovery of the various infrastructure elements that are available and their history. And the IAC Executor Manager executes against some resource providers. So thinking like Amazon, thinking like Azure, thinking like something local, some other public OpenStack installation, things like that. Also on premises, if just a bunch of virtual machines or similar stuff like IoT. And again, this is like a resource provider to this project. Then we also have on the right this infrastructure advisor, which includes things like monitoring, the optimization part of the project. This actually analyzes the deployment and also saves some historical information to the infrastructure elements catalog database. On the left, we can also see the Canary Sandbox tooling that is responsible for spawning the Canary Sandbox resource provider. So like if the user is not able to provide any other resource provider to test it locally and has no experience in deploying projects like Kubernetes or OpenStack, this is a little helper project that is going to help with that exactly. Okay, so I will move forward on that. And I think you've probably seen this image from XKCD. It's quite popular, at least here. So I think I must still answer this question, why are we doing this? Basically because it's introducing another standard, but we believe that also as the people depicted here, that it somehow covers the needs of the use cases better than the solutions that we have nowadays. And our reasoning is the following. So this is a simplification of DevSecOps approach. So the DevOps is quite well understood, but DevSecOps not really, perhaps. Unification of this way. So like the DevOps most of the time is we still seen as something targeting a single environment rather than being natively designed to deploy to hybrid heterogeneous multi-cloud environments. Especially also suggesting that the use of multiple IAC languages is probably more applicable in general solutions rather than trying to stick a particular one single language that is going to target everything, at least with the solutions that we have at the moment. And optimization, of course, and enforcing this GitOps approach that while you with DevOps have moved away from the manual process of approving changes to the configuration, as in some sense the sysadmin when doing the configuration changes was approving them at least by themselves on the machines. Now this approach is going to be centralized in some Git repository so that it's observable and it can be compared to the actual state can be always compared to the desired state of the environment. And now for those key elements that were shown somehow on this diagram that I was showing previously. So this is the DOM, the language for the modeling. It's actually DevSecOps modeling language, but the acronym only uses the DevOps modeling language. Verification tool, that's what was doing that static verification. Then we have this central DOM and IAC repositories. So this was this Git repository tooling. Actually, it it covers the DOM and IAC parts, so that was what was going to live in there. The runtime controller that triggers the actions around the executor manager, the Canary, etc., etc. It will be described on the following slides, so don't worry if you haven't read the slide. Looking at the time. DOM. So DOM, DevSecOps modeling language. The goal of the modeling is to cover all the use cases, at least those that we are aware of. And the goal is to be cloud agnostic able in that. So what we mean by being able to be cloud agnostic, so that it isn't still enforced on the users. So if the users are, for example, very focused on very specific services of one cloud provider and want to stay on that service provider and use those very specific features, then this language is allowing them to do that, basically use all those specific features that may not be available somewhere else, so that the cloud agnosticism is somehow optional but still deserved in this environment. And this is achieved in a very flexible way, let's say, with having modeling in multiple layers that can be presented independently as well. So if we think about the modeling of the application of the infrastructure, mostly in here, we may mean components, connections, different security aspects, properties of that. What are the non-functional requirements, the technological requirements of the desired infrastructure? And we can always apply this at an abstract level that is environment agnostic. So if you are starting from this level, you're allowing yourself to go full agnostic to your environment. So like, for example, you say you have your applications that they require this amount of RAM, this amount of CPU time, etc., this amount of some persistent storage, or perhaps the storage doesn't have to be persistent, like it can always be ephemeral storage because this is somehow not persistent for this application, whatever. Then at this level, you are allowing to just specify that. And then you can say that this model can be satisfied, for example, by the VMs that you have registered in your catalog of infrastructural elements. So like you have those statics, perhaps not even virtual, perhaps you just have physical machines there, and you have them registered, and this can be fulfilled by them, then that's fine, and the model is applicable. Then again, if you have a cloud provider, then if it's possible to find the offer in the infrastructure elements catalog that is sufficient to satisfy those requirements that were given, you are basically going to have this model concretized for you. And then again, you've got this level of concrete modeling where you say that I know this is my abstract model, but I want it to be like this. I want it to be satisfied this way. Like at the moment, I really want this part to use my on-premise virtual machines, but this part I don't really care about. This can go to the cloud, or perhaps the other way around, right? And this is what the concrete level of modeling allows. There are also further levels, like for modeling the deployment of the actual application, because the early levels actually concern themselves only with the infrastructure layer and the requirements of that, but the further levels can specify the application as well. And from this DOM language, we are able to generate some IAC that can be run by the tools that are already available in the market. And the modeling, as I was saying, will be in some kind of Eclipse IDE. I can promise if it will be in Eclipse Classic, the Java-based desktop one, or the Eclipse chip based on Visual Studio Code. So we'll see about that. And onto the verification tool. The verification tool is for that static analysis, and it can see both the DOML, so the different layers of the DOML that were described by the user or by the satisfier, and the generated IAC from that, and based on that, run any possible analysis that can be run statically. Like, for example, imagining if you have this model in Ansible, and this Ansible actually uses some collections, so you can check if the collections are affected by some security vulnerability. Similarly, if it's modeling an application to some degree, it can run the checks for the vulnerabilities in dependencies and things like that, among other things, of course. It also verifies the aspects of correctness. So in the DOM, you can also model, you model it to the level of detail that you can use this verifier tool to actually verify the connections that were expected to exist in the model and generated infrastructure as code are going to be at least tried to be created in this way. And for the dynamics, we'll see another solution later on the latest slide. Okay, so this central repositories, yeah, actually this Git tooling and the runtime controller is what throws everything around there. And what's it for? It's for achieving the single flow that whatever we are doing, we are avoiding the configuration drift by always going from the same central source of information, the single source of truth, basically. That whenever the tooling needs to check whether the infrastructure has drifted away from the desired state, it's in there already. Like the GitOps suggests how it should be done. This also simplifies the management for companies and streamlines this access control, because yeah, all the access control to what is actually going to happen, what is actually going to change in the environment is via this one single, obviously this sounds like a single point of failure, but basically if we consider that the Git repositories can be easily made highly available in such scenarios, then this is no longer a single point of failure. But otherwise, from a management perspective, from the security perspective, this is a single source of truth, the single target for where to look, what the desired state should be. And the runtime controller is, I would say, something basic considering all the other tooling. This is actually based on BPMN, so business process model and notation. It also an extensive vernacular of the operations that are going to be executed in this flow of the operations, but other than that, it's pretty straightforward. That it orchestrates the flow of the framework, actually, only that. And for the IAC executor manager, this is for the execution of IAC, the infrastructure as code. The goal of that is to understand actually what's happening. Like, for example, if the Terraform is creating the resources that the Terraform creates, they are normally tracked like in the same directory that where Terraform was run. With all the metadata that the Terraform has saved there about the resources it created. The goal of this, and similar for Ansible, most of the time people don't even bother saving the information about what was deployed where with Ansible. It just happened. Something happened, and we are fine with that. But the goal of this tooling is so that for this crafted Ansible code, for this crafted Terraform code from the ICG, from the code generator, this tooling is going to be able to understand what was deployed and save this information to the catalog, so that the catalog can be used for tracking the various events, the various metrics that are happening, the various metrics that describe the state of the deployment of the deployed infrastructure elements, things like VMs, the storage that was provisioned, etc. And it also has the support for configuration and reconfiguration, and scaling. So this is actually paramount to be able to make modifications to your code and not trash everything around again. Some responsibility is obviously still on the code generator, on the actual transformation of the DOML, of the input DOML model. But on the other hand, the Arc executor manager, thanks to saving this information, what's already in there, can do a comparison what's going to happen as well. And this automatic deployment to chosen Canary environment, if it's configured, then the process can include this automatically. It could also be a manual process, like from the GitOps perspective, that you could have the branch for what's on the staging, sandbox, or Canary, or whatever to call it, and that would go to that specific environment. Or else the flow could be programmed such that it is always deployed before production, so that if one just goes on a single branch, then at least it is verified in some environment that the infrastructure as code is able to be run, and the tests, if there are any dynamic tests of the environment, if they are provided, they are run in such an environment to verify whether the solution that is going to be deployed is actually not going to kill your production at this point. And it also has to be concerned with the secure access, secure use of credentials to those target environments. And now onto the Canary Sandbox environment tooling. So the tooling that is going to deploy this Canary environment, Canary resource provider actually. There are two main tools in that. The one is the provisioner. So the provisioner, that's what it says. So it provisions the deployments of selected environments like the OpenStack, the Kubernetes, in an opinionated way, so that there aren't many knobs for the users to mishandle, let's say, and simple instructions how to get yourself a ready cloud for yourself at the level of the OpenStack, so the infrastructure as a service, basically, and or the Kubernetes deployment when you are concerned mostly about the containers already, so about the container orchestration. That. And the other solution is Mockler. This actually was born in this project, this idea that there is a need for testing the APIs of the cloud providers, basically not the APIs, but the infrastructure as code that is generated to be operating on those APIs. And whether the state that we at least expect from the cloud providers to how they should behave, whether this infrastructure as code is actually trying to achieve the desired state. So this is mocking up the cloud providers, like for example, mocking up the Amazon EC2 APIs that spawn the VMs on Amazon Web Services. And this is as I was mentioning earlier, this is to be able to test dynamically the aspects of deployment. So like not everything can be tested statically, as we know. So this is a way to do those, let's say, late tests in a known environment, so that you can verify whether the infrastructure as code is going to deploy what you desired to be deployed. And also including those tests, they can also be run in such a deployment, either automatically in that flow or just using another branch for that environment. Infrastructure elements catalog. So this is like a database of what's there, what's deployed, and what's the history of that, what's available also. So this is the central storage, the very brain of the tooling, because it's used by so many components. Also the optimizer that we'll see soon. It doesn't stop there. It doesn't stop at the level of showing what the offers are. It actually tracks the created ones and their state. Like for example, we can understand that this specific zone of Amazon was having issues with the bandwidth for our application. There were latencies beyond what we deem appropriate for our application, so that the optimizer will say, no, we are not going to deploy there because we know it's bad for our application. That's what it's covering in here. And finally, I hope I'm in time still. And finally, the infrastructure advisor. So that's a cool name for this component. It's actually made of many smaller components. I'm sparing you the very details of that, focusing on two most well understood, let's say, the runtime monitoring, which does monitoring for the performance and security characteristics of the deployment that are operating already, and the IOP, the infrastructure optimization platform, that is basically the optimizer, the tooling that is able to look at the deployment and say, well, you could do that thing better due to various reasons. Yeah. So the monitoring bank is the part that is collecting the metrics, the events, and sending it to the catalog, actually where they are stored, and then they can be retrieved by the various other tooling. And it's deployed alongside the infrastructure when at least parts of it are deployed along the infrastructure. So the agents for the monitoring are deployed during the IAM, the IAC execution manager run. Self-learning, self-healing are also included in the stack of infrastructure advisor. So for learning the characteristics using machine learning algorithms, for self-healing in cases where it's obvious what should be done to repair the environment to quickly improve it, so that it is working sufficiently good that it can progress further. That's what self-healing is for. The IOP, the optimization, yes, based on the collected metrics. So that's your optimizer. Integrates with the catalog. I've said that, and the optimization. If we consider the optimization, finally, this is actually balancing the trade-off. So, like, you can't have the cake and eat it. You have to decide what's most important to you. You're balancing the cost, performance, availability, and other characteristics. And based on the weights that you have, the optimizer will be able to read the historic information and new preferences and what's defined in the DOMO as well to give you suggestions on how it's going to be improved. And if you remember the diagram, there was a little arrow from the IOP to the Git repository again, so that the advisor, the name comes from that. The advisor is actually able to advise you what should be improved in that DOMO, in that IAC. Yeah, and concerning the self-learning, this is machine learning. Also in the optimizer, you could say that some of those algorithms are less classic ones, one could say, so machine learning as well. Okay, I think this should be last slide. Yeah. So thank you much. So thank you very much for today for hearing me out. You can stay in touch with us through the project. This is the website, the address of the website of the project. Semmelbus.com is the address of my company. If you want to reach out to me, I'm still available on Slack, and I will be reachable by mail if it can be shared, if you're interested. So thank you.